So yesterday we talked about how to graph a quadratic in standard form, right? There's actually 3 typical formats for graphing quadratics. You saw them all last year. We're going to go back through them. So there's standard form, vertex form, and then intercept form. So yesterday we talked about standard form, right? So what is the standard form of a quadratic? Y equals what? So those of you that took notes yesterday, bust them out. Ax squared plus, yes, in part. So we're going to start there, and then we're going to expand on it. So y equals ax squared plus bx plus c. What's the biggest power on x? 2. So this is a quadratic. In what shape do quadratics make? A parabola. Okay, key values. How do I find the vertex in standard form? How do I find the x-coordinate of a vertex? Negative b over 2a. Once I get my x-coordinate, what do I do with it? Plug it back into the equation. Everybody all right with that, yes or no? There's 3 formats to quadratics. So you know how lines, how we had standard form, and then we had slope-intercept form, and then we had point-slope form? With a quadratic, we have standard form, and we have vertex form, and we have intercept form. So they're variations on the same theme. So they're going to look very similar, but the first couple steps are different. So what you're going to do is when they ask you to graph the quadratic, you have to identify, is it in vertex form, intercept form, or standard form, and then use the appropriate pieces, so that way you can actually find your vertex and make the graph. So everybody all right with how to find the vertex in standard form, yeah? All right, min-max. When do we have a minimum? When the graph points which way? Up, which means that A is what? Positive. So when do we have a maximum? When the graph points down, which means A is negative. So minimums are when A is bigger than 0. Maximums are when A is less than 0. Axis of symmetry. What kind of a line is going to be the axis of symmetry? Dashed, and is it vertical, horizontal, or skew? It's a vertical line, so it's x equals negative b over 2a, right? Now, the negative b over 2a, where does that come from? The x-coordinate of the vertex, right? Everybody all right with that, yes or no? So the axis of symmetry has to pass through the vertex, so the x-coordinate of the vertex is going to be how we find the equation of the axis of symmetry. What I want to stress is when you write out the axis of symmetry on a quiz or a test, you have to write it as an equation. If you put 5, you're wrong, because I don't know what 5 is. If you put x equals 5, oh, I know that's a vertical line that passes through 5. Everybody all right? So you have to write it out as x equals here. So please be careful. But everybody good with standard form from 4.1? Okay, so moving on, vertex form. So vertex form is obviously going to give us the vertex. Does anybody remember from last year what vertex form actually looks like? Okay, so it's going to be y equals a times the quantity of x minus h squared plus k. H is going to represent our horizontal shift, and k is going to represent our vertical shift. That's very, very common that we use that, because you would have seen it before when I wrote out absolute value functions, right? It's the same h and k. H represents a sliding to the left or to the right. K represents a slide up or down. All right, so the shape, what's the biggest power you see? 2. If the biggest power is 2, is it linear or quadratic? Quadratic. So if it's a quadratic, what do we call the graph of a quadratic? A parabola. Everybody okay? All right, key values. How do I find the vertex? Well, if this is in vertex form, that means that it's going to have the vertex equation in its structure. So if you notice, H, again, that's horizontal shift, right? Left to right, which means that's an X shift. K is going to be our vertical shift, which is up and down, which is a Y. Everybody all right with that? Okay, so the last check, or the important thing, is that H comes from inside the parentheses, and is H positive or negative in this equation? Negative. What about here? Positive. So what does that mean? H is going to what? So H is going to always flip its sign. What about K? Is K positive or negative in the equation? And the point is it's positive, so it always keeps its sign. Everybody okay with that? Yes or no? H always flips its sign. So if it's a negative in the equation, it'll become a positive in the vertex. If it's a positive in the equation, it'll become a negative in the vertex. And K always stays the same. Yeah, they'll always match. So the main thing is like standard form, right? Do you see any parentheses in standard form? No. Okay, in vertex form, you have one set of parentheses with a power of 2. If you have that format, that'll be vertex form. Okay, Min-max, when do we have a minimum? When A is what? Greater than 0. That has not changed. When do we have a maximum? When A is less than 0. Axis of symmetry. Is it going to be a vertical line, a horizontal line, or skew line? It's still going to be vertical, so I got to find it here. There it is. So it's still an x equals, right? But over here, why was it negative b over 2a? What was this negative b over 2a referencing back to? X coordinate of the vertex, right? So over here, what's the x coordinate of the vertex? H. So what's my axis of symmetry equation? X equals h. All right, so very similar stuff, right? A lot of it corresponds. Finding the vertex is the most important step you have. If you find the right vertex, then you can make your chart, and then your chart's right, and then your graph is right. If you find the wrong vertex, your chart's going to be off, which means that your picture's going to be off. So it all hinges on being able to find the appropriate vertex. So the main thing that you need to focus on is for the 3 different styles of quadratic, how do I find the vertices? So intercept form. Standard form for our intercept form. So, wow, that sounds weird. How about standard equation for our intercept form? Is going to be y equals a times x minus p times x minus q. So on Friday, I started talking about these a little bit, and I said we'll talk about it later. So let me write these out. Okay, so if I write that out, right, roots, zeros, intercepts, solutions. All 4 of those terms actually mean the exact same thing. So when you think of roots, what do you know about roots? And I'm not talking about like the awesome band, but like where are roots? In the ground, right? So if I were to turn the world into an axis, is the ground going to be a horizontal axis or a vertical axis? Horizontal. So for us, roots are where the graph crosses the horizontal axis. Okay, when we say zeros, we're implying y equal to 0, which means we're on the horizontal axis, correct? Intercepts, these are actually x-intercepts, and then solutions. So all 4 of these terms mean the same thing. And what they mean is, where does the graph cross the x-axis? Why that matters is that tends to be where important things happen. So in actual application, we tend to focus on 2 key areas, x-intercepts and vertices. So where is it reaching its max? And then what's happening when it hits 0 again? What is going on? That's what we really care about when it comes to most quadratics applied, because we deal with real world, right? Where 0 is usually the ground or a person or a place. So once it hits that, we really don't care. So I just want you to know that these 4 words mean the same thing. And again, why would I go through this? The ACT. In one question, they'll say, find the roots. And then in the next question, how many zeros? And then they'll say, find the x-intercepts. And if you don't know the connection, your brain's going to be like, wait, we didn't talk about roots in class. Yeah, we did. We called them solutions. Okay? So if they say, how many roots does the quadratic have? All I'm asking is, how many solutions does the quadratic have? How many zeros? The 4 terms are all interchangeable. Okay, so the main thing is that you get past the language barrier. So when you're taking the ACT and you see the word solutions, intercepts, zeros, or roots, your brain can go, oh, wait, that's where do we cross the x-axis? And that's all I'm trying to find. Okay? Shape. How many x's do you see up here in our general equation? 2. What are we doing with those 2 x's? Are we adding them, subtracting them, multiplying them, or dividing them? Multiplying. So what's an x times an x? X squared. If the biggest power is 2, what's its shape going to be? A parabola. So again, we still have parabolas. All right, the vertex. Anybody know how to find the vertex in intercept form? Nah? All right. So let me draw it out. So if I have a quadratic, any quadratic, and I want to find the vertex, right? This is called intercept form, which means that it's going to tell us where the graph has intercepts, which means it's where the graph crosses which axis? The x-axis. So the values of p and q are actually where does the graph cross the x. So this is going to be a p, this is going to be a q. Okay, now if these are my intercepts, because the graph is symmetrical, what that means is that the vertex has to be exactly in the middle between p and q. So this is my p distance, this is my q distance, my vertex is exactly in the middle of those 2. So if I asked you to find the middle value from 2 endpoints, Who remembers how to find the middle point? Add the two numbers and divide by 2. Find the average, right? If you're 5 units away from a place and the other person's 3 units away, right? How far, what's the middle between the two of you? Well, 5 plus 3 is 8 divided by 2. So 4 units will be the exact middle between you and where the other person's standing. All right, so we're going to take P plus Q, which is the total distance, and then we're going to cut it in half to find the middle. Well, for us, that middle point is going to be the vertex. All right, so we're going to use the symmetry of the graph in order to find where our vertex actually is. So if we come back over here, the x-coordinate of a vertex in intercept form is P plus Q over 2. And again, if you notice, or what's the sign on P in the equation? What's the sign of P at the vertex? So what's it do? Changes its sign. What about Q? Negative to positive, so it changes its sign, okay? If you want to, you can FOIL it all out and then just graph it in standard form. So for the vertex, once I get the x-coordinate, what do I do with the x-coordinate? Plug it back in. So I find the y by evaluating my f of x. So the x-coordinate is the P plus Q over 2. Once I get the x-coordinate of the vertex, I plug it back in to find the y that matches with it. Everybody all right? When do we get a minimum? When A is what? Greater. Maximums are when A is less than, right? Okay, axis of symmetry. Vertical, horizontal, or skew. Vertical, so it's going to be an x equals, right? And this time you're going to tell me, what is x going to be equal to? What would I write in here? P plus Q over 2. Because the x value for my axis of symmetry is going to be the x value for the vertex. All right, so if I said graph this quadratic, the first thing you need to do is identify what format do we have. So is this standard form, vertex form, or intercept form? Vertex form. How do I know? One set of parentheses squared. When you see one set of parentheses to a power of 2, vertex form. So in standard form, we found A, B, and C because those were the key values, right? If you go back to your notes for vertex form, what are the key values when I wrote out the equation? A, H, and K. So that's where I'm going to start. Just like I started with A, B, C in standard form, A, H, K in vertex form. So what is my A? -4. What is my H? -2. Very good, because it's in parentheses, so it's got to flip. And what's my K? 5. Whenever you graph a quadratic, the first thing you need to find is going to be your vertex, and then you want to find your axis of symmetry, and once you have your vertex, you can make your chart off of it. So my vertex is going to be what coordinates? H and K. So what's my H? And what's my K? So there is your vertex, done and done. So where's my axis of symmetry? X equals what? -2. So now, make my XY chart. What goes in the middle always? The vertex. I need two numbers bigger, so give me two numbers bigger than -2. -1 and 0, give me two numbers smaller than -2. -3 and -4. Everybody all right so far? Okay, now, when you actually evaluate this, I have powers and parentheses and all that stuff. So what I'm going to do is I'm going to use my order of operations. So when it comes to evaluating this, right, order of operations, what do I use first? Parentheses and then what? Exponents and then the multiplication and then the addition, right? So I plug in my -1 for x. I have to do what's inside the parentheses first. So what is -1 plus 2? +1, right? So that's the P done. And then I can do the E, the exponents, right? So what's 1 squared? 1. And then I multiply, so what's -4 times 1? -4 plus 5, +1. Everybody okay with the order of this? If you're using a calculator, you want to type it in exactly the way it looks, including parentheses. If you do not include parentheses, you are wrong. So plug in a 0. What's 0 plus 2? 2. 2 squared? 4. 4 times -4. -16. -16 plus 5? -11. So make sure that when you plug in here, you just work inside out, right? Parentheses, power, multiplication, addition. Up next is -3, right? 1. All right, and then for -4 is -11. All right. So now it's just like everything else we've done. I start off with my axis of symmetry, which is going to be what kind of a line? Solid or dashed? Dashed line. Vertical at x equals -2, right? All right, I'm going to change my y scale to count by 2s. And then I still want to mark my x scale so that way the reader knows that I didn't change both scales. Everybody good? All right, where was my vertex? -2, 5. All right, at -3, I was at 1. At -1, I was at 1. At 0, I was at -11, right? And at -4, I was also at -11. All right, so again, is this pointing up or down? Down because A is negative, right? Can everybody see that it has the U shape to it? All right, so before you graph your line, you want to check and make sure that it has the U shape, right? If you plot your points and you're getting a straight line, then your table is wrong or your vertex is wrong, something along those lines, okay? So that doesn't mean keep going. That means stop, go back, and figure out what's broken and fix it. So you start at your vertex, curl down through your points as best as you're able to here. And the only thing that's left to do is to label. So label your axis of symmetry and label your vertex. And as you can tell from the graph, right, if I looked at the intercepts, they would be here and here. And the vertex is exactly where? In the middle of them. Everybody okay with that? So for intercept form, we're going to be using that connection. What format is this in? Standard, vertex, or intercept? Intercept, how can you tell? 2 sets of parentheses, okay? So what are my key values for intercept form? A, P, and Q. So what's my A? 2. What's my P? -3, good catch. And what's my Q? +1. So remember, whenever you have parentheses and you pull a number out, you have to flip the sign. So find the vertex. So how do I find the x-coordinate to a vertex in intercept form? P plus Q over 2. So P plus Q over 2. So what's my P? -3. What's my Q? So I get -3 for my P, 1 for my Q, all over 2. What's -3 plus 1? -2. So what's -2 divided by 2? -1. So that is the x-coordinate to my vertex. How do I find the y-coordinate once I have the x? What do I do with it? Plug it into the equation, right? Now, take a look at my equation up here. How many x's do you see? If there's 2 x's in the equation, how many times am I going to be substituting in my value? Twice, right? So each x gets replaced with my x-coordinate. I always have students who make mistakes with that, so be careful. So I'm going to take my statement to find the y and just replace x with my x value. So I get 2 times the quantity of -1 plus 3 times the quantity of -1 minus 1. Order of operations says I do what's inside the parentheses first. So what's -1 plus 3? 2. What's -1 minus 1? -2. And now I just evaluate. So what's 2 times 2? Times -2. So my y-coordinate is -8. I need to find my axis of symmetry. So again, it's going to be an equation, right? So it's going to be x equals, and which value do I use for my axis of symmetry? Okay, so the x-coordinate out of the vertex, right? So according to my vertex, what's my x-coordinate? -1. So that is the equation to my axis of symmetry. All right, so finish it off real quick here. Make an XY chart. What goes in the middle? The vertex. So I put in -1, -8. I need 2 x's bigger, 2 x's smaller. 1, 0, -2, -3, right? Now, the only thing is that you're going to have to be careful when you substitute here because you have to work each parenthesis separately, then multiply. So when I plug in the 0 here, what's 0 plus 3? 3. What's 0 minus 1? -1. So this becomes 2 times 3 times -1. So what's 2 times 3? Times -1, -6. Everybody okay with how I'm evaluating that? Again, if you want to use the calculator, you're welcome to, But you have to type this statement in exactly the way it looks. 2, parenthesis, 0 plus 3, close parenthesis, open parenthesis, 0 minus 1, close parenthesis. All right? If you use your calculator, you have to make it look exactly like our statement. Otherwise, you're guaranteeing you will get the wrong answer. All right, so plug in a 1. What's 1 minus 1? 0. What's 0 times something? 0. What's 0 times 2? 0. So there you go. Yeah, that one worked out really nice. That's pretty. So plug in negative 2. What's negative 2 plus 3? 1. What's negative 2 minus 1? Negative 3. So what's 2 times 1? 2. 2 times negative 3? Negative 6. What's negative 3 plus 3? 0. What's 2 times 0 times something? 0. Everybody okay? Everybody okay with graphing? Right, same old, right? One last thing that we need to cover, and then you'll get your homework assignment. Does everybody in here remember how to FOIL? Okay, what does FOIL stand for? First, outside, inside, last. For the record, I hate that term because it only teaches you how to do a 2x2. Well, what if you have 2 terms and 3 terms? You can't FOIL it. You have to do something else. So what we're really doing here is we're doing the distributive property, right? If I wrote up 5 times x plus 3, how do you distribute that? What do you do? Okay, 5 times the x and then 5 times 3. We're doing the exact same thing here, but how many terms does this first piece have? 2. And how many terms does this piece have? 2. So what that means is in order to multiply these, I have to take every term from the first set of parentheses and multiply it with every term in the second set of parentheses. So I go x times x, first term in the first set times first term in the second set, right? And then I have to take x times the negative 1, first term in the first set times second term in the second set. If there was a number past the negative 1, I'd have to take the x times that as well. Everybody okay? So this is just a giant distributive property. So, and then I take 3 times what? The x, right, second term in the first set times first term in the second set, and then take the 3 times the negative 1. So I take the second term in the first set times second term in the second set. And I keep going until I'm out of numbers. Okay? So, real quick, who remembers what's x times x? X squared, x times negative 1. 3 times x. 3 times negative 1. Okay, is there anything here that can group up? Okay, so the x's can combine. So what's a negative x plus 3x? Positive 2x, right? So now, if you notice, what form is this equation in? Standard form. So this is like what I was saying to Carly if you didn't catch it earlier. If you don't want to use intercept form, you can FOIL out and get standard form and then graph using the negative b over 2a. Or you can use the p and q up here. I don't care. Just be accurate and be consistent. All right, so here's your homework.